So I think thank you very much, Create, and as well as the Create entities for inviting URA this afternoon to share with you how we see the application of R&D to support our effort to build a more livable and resilient city. So for planners, we seek to develop a city that in a sustainable way to meet the needs of the economy, for the society, as well as the environment, and in Singapore in particular, in a way that optimizes our limited land and sea space. So this requires us to make every component of the city work, but at the same time, also taking into account the interdependencies across these different parts. With a highly built up environment, with an aging population and infrastructure, with a rapidly evolving economy with the new kinds of technology, at the same time with the trends in climate change, our operating environment is becoming more complex. And there are many more uncertainties that we have to plan for. Nonetheless, with a lot of increasingly better data that's collected, with the analytics and simulation capabilities, as well as more collaborations that's taking place across the ecosystem, there are also a lot more possibilities for us to reduce the uncertainties that planners have to deal with. And I think the capabilities itself also allow us to better anticipate what are some of the outcomes in the years ahead. So this enables planners to make better planning decisions. I think at the same time, the new capabilities and technologies today, it also introduces new solutions to meet the challenges we face. There are 5 key lenses that URA is focusing our efforts for R&D and collaborations on. This includes transport and urban logistics. How do we build an age-inclusive environment, underground space planning, creating a livable, high-density towns, as well as better resource management. Over the last few years, we have collaborated closely with several Create entities. So this includes our collaboration with Future Cities Lab to look at how do we calibrate and validate the MedSim model. This gave us a better understanding of travel demand patterns in Singapore and also enabled us as planners to better understand the potential as well as challenges in the use of agent-based modeling. We also collaborated with the Future Cities Lab to understand the quality of our walking pathways, and this has subsequently developed into a walkability tool that today guides the way we design our walking environment. This also cascaded and led to a more expanded collaboration that now involves 5 research entities and 3 agencies to understand the issue of pedestrian comfort. This is a project that's ongoing, and it will certainly help us better improve the quality of our walking environment. We're also collaborating with both Future Cities Lab and the Smart FM to better understand how do we plan for our new towns to be able to incorporate infrastructure to support the use of autonomous vehicles and also build up a better understanding of how freight vehicles travel in Singapore. And that is the study with both Smart FM and SUTD. In particular, for the freight study, we also collaborated with HDB to deploy transponders on the heavy vehicles that utilize our season parking tickets. And this allows us to actually monitor the movement of these freight vehicles to collect better data. Currently, we are also working with the Future Resilience System program to study how can we better understand the resilience of our public transport system that incorporates both the rail and bus services. Beyond the research projects, we have also been engaging with various Create entities quite closely. I think we participated in several of the scoping workshops, and most recently was the one for Future Resilience System. Future Cities Lab also participated in our Urban Lab exhibition that was held at the URA Center. The Future Cities Lab track that looked at cycling also participated in one of our parking day events where they interacted with the community, and through that exercise also got significant understanding on how people appreciate the different kind of cycling environments. We also had good support from the Future Cities Lab in the Advanced Urban Design course that was held internally in URA for our architects. Beyond that, we have also worked with Create entities to organize talks to connect our planners as well as our partner agencies with the kind of related research that is taking place within the Create entities. So this includes the talk by Andreas that talks about how BRT systems can enhance the public transport system to be more efficient and also create a better experience for the commuters. We also had significant inputs from Stefan early this year based on the studies that was done in Switzerland on future energy systems. And this was incorporated into our study of how can we better plan for the kind of energy technologies going forward for Singapore. Going forward, we want to continue this collaboration with researchers to further develop the capabilities within the 5 lenses I mentioned earlier, but really to support both the spectrum from planning all the way to resource management. And we want to work on 3 key thrusts, which is on mapping, modeling, and simulation. How do we better improve data analytics, and including predictive analytics? And how do we also harness the capabilities of artificial intelligence? Together, this will help us have a better understanding of what is the existing baseline condition. Going forward, how do we better optimize our resources? And we want to be able to translate the findings from this research into the way we do our plans, as well as our policies. To support this, we certainly invite researchers to work with us on topics of common interest, where we can work together in a common space where this research can take place. And it includes both longer-term research as well as shorter, rapid prototyping. And these results can then be shared and applied for both academic purposes as well as in our plans and policies. So thank you again for inviting us to share with you some of the areas of interest, and we certainly value the partnerships from the various creative entities over the years. And we hope that if there are any interested researchers, do approach us to explore new areas that we can work together on going forward. Thank you.
Great, thank you very much, Mr. Huang. I'd like to open up the floor to for any questions. No one is? Okay. Okay, well, Michelle, what do you?
Thank you very much. We'd now like to invite Professor Gerhard Schmidt, Director of the Singapore ETH Centre, to position Create's research strategies regarding the challenges set forth in Mr. Huang's talk. Professor Schmidt is a Professor of Information Architecture at the Swiss Federal Institute of Technology Zurich, more widely known as ETH Zurich. In 2003, as Vice President for the Planning and Logistics and member of the board of ETH Zurich, Professor Schmidt initiated Science City, ETH's new campus in Zurich, which is a revolutionary interchange between ETH Zurich and the public. In 2007, he convinced the ETH board to start the transition of ETH Science City towards a zero-carbon emission campus. Professor Schmidt's efforts in developing and transforming ETH Science City earned him the European Culture of Science Award in 2010. Professor Schmidt and his team also developed the Future Cities massive open online course series in 2014, which, now in its 4th edition, has engaged over 120,000 participants. At the Singapore ETH Centre, he initiated the simulation platform for the Future Cities Laboratory. He now leads the InterCreate Cooling Singapore project, as well as the Big Data-informed Urban Design and Governance project. Please welcome Professor Schmidt to the stage to convene the Urban Systems session. Thank you.
Thank you, Michelle. Ladies and gentlemen, it's a great honor to be here. I really want to thank not only you, our teams who are working together here, but also the people who made it possible, Prof. Loh, Dr. Lim, and also a person I see in the audience, P.C. Louis, who was very, very instrumental that we can sit here. Actually, 9 years ago, we were standing here in the mud before it all started. This is about urban systems, because all entities at Create who deal with cities see very quickly it is really about systems, urban rural systems, and everything that belongs to it. These views you probably know from different presentations in the past. The light indicating activities in a certain settlement, density, and so on can be seen with this. And these maps you also might have seen before the world in 1950, when everything was settled in the world, but not so densely, and the world in 2030, as it is expected, and we can see it's an incredible explosion of human settlements all over the world. This means the cities are not separate from each other anymore. They are really forming large systems across continents, and not only the land is being settled, but also the entire sea. Urban planetarization, as we call that. Singapore itself is also not a city by herself, standalone. It is surrounded by many other cities already. In the south, you can see at the last year, it was actually the fastest growing city in the world, Batam, with more than 3 million inhabitants by now. In the north and in the west, also enclosed by growing cities. So this is an urban system, a very large urban system already. What do we look at? The different parts of CREATE have different focus areas, and they all can be broken down into these parts: energy systems, infrastructure systems, transport systems, urban ecosystems and circular economy, smart and responsive systems, and urban climate design systems. So we want to focus on some of those, not in great depth, but that you have a glimpse what all the things are that are going on here. Urban energy systems. An image taken just a couple of years ago from a high-rise or from a restaurant in Singapore, looking down on Singapore and looking towards the west, and you can pretty much imagine what is going on there. On one side you have the energy consumption, on the other hand you have the energy production, and it is quite a densely interwoven system. Reflecting this morning's first talk, it is very important to understand why these flows of energy are happening in this way and what we can do about it. There is a special program in Future Cities Lab called the Multiscale Energy Systems for Low Carbon Cities that observes and calculates and simulates from the building scope on the left, building scale you could say, over to the right to on-site energy production, to district energy production, to changes in urban form that might be caused by this or be a result of this. There's also a project that we saw briefly in the video this morning, the Waste to Energy Solutions from the E2S2 program with NUS and Nanyang Technological University, and Shanghai Jiao Tong University. And you can see the different cycles they are exploring and also how they create pilot scale test bedding of complete waste to energy systems for food and other rests of animal waste. So these are on the small scale to medium scale. But then, of course, we have larger scale systems, like the urban infrastructure systems. And these are not just streets, but of course, Singapore being the second largest port in the world, this is a very important part of the system. By the way, also producing lots of emissions which reach the city every day through the ships that are coming through the port. The Future Resilient System program is focusing on changing the resilience paradigm that we have today, and you can see all the components they explore, from the power lines to the streets to the other elements in the city, in the urban system that they want to explore. And you see in this slide also from the Future Resilient System the important focus on behavior, and behavior is always either system behavior, but more important, human behavior or organizational behavior that you can see there. And that brings to the front more and more the role of the human in all of these projects that we have, because without the human they cannot work, and they are also hardly to be controlled. The critical transport resilience, to make sure that after accidents or catastrophes the urban transportation system is working, and even better working maybe than before, we saw in the previous presentation from Mr. Huang, and this is a very important aspect of urban transport and urban resilience. But there are other things that are relatively new. Between the LTA and the city of Zurich, or the city of Singapore and the city of Zurich, a new project has emerged, which is exploring the urban underground. This is not, Digital Underground is not a political party or a band or something. It is really exploring what is underneath our cities, which is much more, sometimes more important than what is above the ground. And these two units have found together and have signed a contract and to develop guidelines for 3D mapping of utility networks below the ground, and that could expand much more. Urban transportation systems are a big part of many units in the whole CREATE campus, and we will see from our colleagues from MIT and also from TU München at the end the very interesting specific applications of that. Here the MatSim program that was also mentioned just before, and you can see here the different functions that people have during the night and the different parts of the day, how they interact, and the whole island of Singapore with the 5.3 million people was simulated as an agent-based program that you can see here. Very helpful for making decisions for the future. The question of autonomous vehicles, you could see it in front of the building, and you can see it every day increasingly. You could see it in the video. You will hear about it much more in a few minutes. But this is also part of the research of FCL at one point, and very important, the L2 NIC joint projects that are between different agencies and between different parts of CREATE campus. Here again, the user or the citizen, the active mobility becomes an important issue. It's not only urban mobility with cars and bicycles and so on, but it's active mobility by people walking. So that means cyclist-friendly street design or pedestrian comfort in high pedestrian activity areas. And you can see all the tools that we develop and also use quite a bit. The simulations having the same problem as the video this morning, but maybe it's working now. The people are walking a bit strangely here. Normal people work much more elegant, but it is meant to give the impression of people sitting on this bike and actually seeing that in VR, and that can then be used to decide if the street should be wider or narrow, or if we have to add trees or do other things to make the experience better. And that pedestrian comfort brings us back again to this morning, to the first part, because if there is no will or capability to walk, then comfort, pedestrian comfort is not very helpful. But if we can achieve to make the city a bit cooler and calmer, then pedestrian comfort becomes a big, big issue, and we will see much more of this in the coming years. Urban ecosystems and circular economy are also big names or big themes in the CREATE enterprise, or in the CREATE environment. What does it mean? There's a whole lot of projects focusing on, for example, one big one, dense and green building typologies, the beautiful buildings that have been generated in Singapore in the last years, which bring really greenery in the city, but in a different way than just putting flower pots on the balcony as it's done in Europe sometimes. But this greenery takes on its own meaning, and we can start to see that as part of the ecosystem services that we will discuss later. It is also part of this new project that Peter Edwards mentioned this morning that will start 2018. It's called Ecosystem, Assessing Singapore's Natural Capital, where different agencies and different units, again, SMART, NUS, NTU, and NParks, work together to assess really the incredible value that the ecosystem has. So there's some old numbers, not old, but numbers from 20 years ago already, that the world's ecosystem or natural capital was estimated at $33 trillion when the global GDP at this time was only $18 trillion. By now, unfortunately, probably it is not the same anymore, and the estimated $33 trillion at the top have probably gone down. But in order to know, we have to study this, and we want to study this for Singapore because that will be very, very important for the future. This is not only happening in Singapore, as you can see here. This is on the fastest growing city in the world, in Batam, where groups of young people working together with people here from the Future Cities Lab, and just last week they have inaugurated the first building of this type, which is not just a building, but it is a system, again, that can be expanded horizontally and also vertically for the future. It doesn't stop there. We have to go to the very small scale, which is the material. And we had many different types of materials developed here at the FCL already. The one that's known from the past is probably the bamboo material, the Advanced Fiber Laboratory, as it was called. But more recently, also material is mycelium, which was used from waste in the past and which is grown and used for building wonderful new structures. Here, this has made it all the way into the Biennale in Seoul. This huge structure combination of this mycelium with the advanced fiber material developed in the lab over here and making a very, very sturdy structure, which is a totally new way of looking at constructions for the future. Everybody's talking about smart cities today, so we have a lot of smart city systems work here at CREATE. Big data informed urban design and governance is only one of them. Interestingly enough, we found an old image, a postcard from 1906 somebody had sent from Singapore to Great Britain, and this was actually quite a smart system at this time already. It was the electric tramway power station in Singapore. So we had these systems long time before. One wonders why they disappeared, because many of these things we are looking for again today. And one of the most advanced technologies and methods we are using to explore and to understand the dynamics of the city is urban complexity and complexity science, to reveal these hidden rules for the dynamics of cities. And this is amazing, because all these data and numbers, you suddenly can make sense and you can predict part of the development of a city. Big data, blockchains, IoT, this is very quickly developing in many parts of CREATE, and we will see a lot more to come in this. But there's the other side, is the citizen. How do the citizens react to that? So the citizen engagement is very important, and we call that not smart cities, but what comes after the smart cities, the responsive city. And here, that is citizen engagement. You see almost like a mirror from Mr. Huang before, because he showed it from the URA side, we show it from the other side. It's the same people engaging in this future mobility. And it goes even further, that citizens start to design their own future living part. You see Tanjung Pagar, which is the harbor now, which will be moved. Citizens are starting to think, how could it be in the future? And you see how citizens from Singapore, but also from all over the world in our massive open online courses, start to design very, very simply on the web different alternatives for this new development. So that's maybe an interesting input also for the URA and other agencies, because that comes really from the people. And here you see a number of many hundreds of these proposals from the people for this new area in Singapore. The final part is this urban climate design. You heard it from Peter Edwards this morning. We are convinced it is not enough anymore to plan the city just two-dimensionally or even three-dimensionally. We always have to think of the urban climate, because the urban climate is not stopping at the floor plan. It's moving in all kinds of directions. And these first maps we get here are very fundamental for that. From these maps we can discover where we are lacking information and where big mistakes in these simulations are. So this will be a very important area for the future as well. I want to stop here briefly and want to give the word now to our colleague, Dr. Fang Xiao. She's the principal research scientist from the Future Urban Mobility Group from the Singapore MIT Alliance for Research and Technology. Fang?
Thanks, Gerhard, and very good afternoon to all of you. I'm very honored today to share with you the research program that's being carried out in the Future Urban Mobility Group in SMART. So in SMART, we work on a wide range of projects focused on urban mobility solutions, as the name implies, and most of them fall under the urban transport system that Gerhard mentioned earlier. For these whole group of projects, we have a common underlying motivation, which is to unleash the power of distributed and networked sensing, computation, communication, control, and feedback systems to enable the future urban mobility solutions. All these capabilities are actually well exemplified by a smartphone nowadays, which has multiple sensors, advanced computation power, ways to give controls and give feedback, and everything that we need to put the city at our finger point. So equipped with all this technology, we're working on a number of projects, and to be exact, we have 12 ongoing projects in Smart FM, and that ranges from strategic land planning, to, urban designs, to new parking business models, from driverless cars and connected vehicles to connected persons and pervasive data collection. So these projects are led by 7 MIT professors and 15 professors from the various local universities, and altogether there are more than 200 researchers working on these projects. And of course, we have collaborations with a lot of universities, agencies, and industrial partners around here. Although most of these projects are currently being focused on context in Singapore or being piloted in Singapore, our goal is not just to stop here, but rather to build mobility solutions that are applicable to many places, many cities around the world, to enable Singapore to become a technology leader in the realm of urban mobility. For the 12 projects, we roughly organized them under 3 main pillars. So on the right-hand side, in the gray zone, we have devices and systems. Basically, these are technologies using focus on mobility sensing and safe and affordable autonomous driving. We also have a second pillar, which is on control optimization and planning. These are focused on mobility management systems and real-time mobility estimation, prediction, and control systems. And finally, we have the pillar on the left-hand side, which is on modeling and simulation assessment. And under this pillar, we're developing a very comprehensive simulation platform called SimMobility, which I'll discuss more in a few minutes. But this picture actually gives us a high-level overview of what we're doing in FM Smart. Due to the interest of time, I will not go into all the details of each project. You can see, if you're interested, you can see more details in the posters on the second floor. But I'm just going to share with you 4 stories of the projects in FM Smart. So the first one is on our autonomous vehicle project. So I assume most of you have already seen demos of the autonomous vehicles outside the theater. So the AV project in MIT actually started way back in 2007 when the MIT team participated in the DARPA Open Challenge. Now, the project has been further developed under the FM program here in SMART since 2010, and the vision back then was to develop affordable and reliable self-driving technology. So in 2014, the autonomous buggies developed by SMART were deployed in Chinese Garden and Japanese Garden here in Singapore to allow public to have trial runs. And that was the first public trial of autonomous vehicles in Singapore. Since then, in 2015, Newtonomy, which is a startup company based on the AV technology, has been established in Boston and in Singapore. It has expanded rapidly and has made great strides into commercializing the software, the technology, and bringing AV to our streets. Within SMART, the researchers are also making further developments. So they're not just focusing on autonomous cars, they're also adapting the AV technology to personal mobility devices, such as wheelchairs, scooters, and buggies. I think there was a wheelchair outside just now as well. I'm not sure any one of you have tried that. So these devices actually move the autonomous vehicle technology closer to people, and it makes it available to places of non-roadwork infrastructure or even indoor settings. And this enables people to be able to have an end-to-end trip on autonomous devices, from wheelchair to cars, and maybe to wheelchair again. And actually, the autonomous wheelchairs were piloted in last year in conjunction with Changi General Hospital. The second project I want to share with you is called Future Mobility Sensing. So it's a smartphone-based travel survey system. The idea is that traditionally, a lot of cities around the world actually conduct regular household travel surveys. For example, in Singapore, LTA carries such surveys once every 4 years. And in those surveys, a lot of surveyors are sent out to interview people and understand their mobility diary of the previous day. So they ask very detailed questions like, what time did you leave home? What mode of transportation did you use from home to work, where did you transit, and so on and so forth. So that's a very time-consuming process. At the same time, nowadays everybody has a smartphone with them, and the phone actually can collect the information at a very high accuracy level that's relevant to the survey. So our goal is to automate this survey process as much as possible by installing smartphone apps on iPhones and Android phones. So we piloted this project with LTA again in 2012, 2013, in conjunction with the household travel survey back then, and was very successful in demonstrating the capability of this new technology in collecting high quality and multi-day data from individuals. So in 2014, a startup company called Mobile Market Monitor has been established, commercializing this technology. And right now, its software is being used in several cities around the world to carry out large-scale household travel surveys. Within SMART, we're not stopping our development of FMS, and in fact, the researchers are still pushing the boundary of FMS to develop new ways, innovative ways to collect data. So one of the projects we're currently engaged in is what Mr. Huang mentioned just now, the urban freight and heavy vehicles study, where we collect data from trucks, from shipments, to understand the goods movement in Singapore. The third project I want to share about is called Treepedia, which is an interesting name. So the researchers in this project use Google Street View to measure the trees and vegetation coverage of various cities around the world to form a green view index. So they do so by getting the images from Google Street View and then use computer vision techniques to try to compute the canopy coverage percentage of each city. And the score is on the 0 to 100 scale. So right now, the research work has already covered 17 cities around the world. And among these 17 cities, which one would be the greenest of them all? Actually, Singapore ranks the highest in this study with close to 30% canopy coverage, which we should be very proud of. It definitely deserves the name of Garden City. And followed by, in the second place, it's a tie by Sydney and Vancouver. And among these 17 cities, Paris actually ranks the lowest with 8.8%. So just for your information. And the last project I want to talk about today is Symobility, which I briefly mentioned earlier. It's a comprehensive mobility simulation platform, which we aim to be the nexus of mobility solution evaluation tool. So the idea of Symobility, you can roughly think of it as a SimCity for transportation system, in which there are millions of little agents moving about using the transportation system. And in Symobility, we have many models organized on three different timescale terms. So we have models that simulate decisions on short-term scale, which is on driving behavior, short-term decisions such as acceleration, deceleration, lane changing, stopping at traffic light. And then we also have models simulating the midterm behavior, which is decisions such as where should I go tomorrow for dinner, where am I going shopping for grocery, and which mode of transport am I going to take for tomorrow's trip. And also it has simulation on long-term decisions, such as where am I going to buy my SDB flat? Where am I going to send my kids to school? Where should I choose my work location? So all these put together give us a comprehensive view of the mobility system, and it can be used by planners or by transportation agencies to simulate future infrastructure changes or new policies before they actually put down the investment for these changes. So that actually covers the highlights of the projects in Smart FM. And as I mentioned, we have posters upstairs to show more details. Thank you very much.
Thank you very much, Fang. And in this continuation of the mobility, which is a very strong urban system, I want to call to the stage Ulf Schlichtmann. Professor Ulf Schlichtmann is the program director of TUM Create, and he and his team prepared the work that we will see now. Ulf?
Okay. Thank you, Gerhard. Ladies and gentlemen, very warm welcome. I would like to give you some idea of what we're doing in TUM Create in terms of transport. Specifically, we are looking at public transport. And we set out our mission, a lofty goal to seek the ultimate public transport system for the people of Singapore. And as you will see in a moment, it will be a road-based transport solution, so not rail-based, in order to reduce investment cost, which should give very positive travel experience to people. The idea being, we want to encourage people to use public transport, not because individual transport is very expensive over here, but because public transport really is very attractive because it's the mode of choice. That's what we're trying to achieve. And that fits in very well with various initiatives and goals that Singaporean agencies have set out, as you can see here, starting, for example, with the LTA Transport Master Plan from 2013, which asks for 75% of trips during the peak hours to be done by public transport. 85% of all public transport journeys should be less than 1 hour. LTA and ITS focused in their Singapore Smart Mobility on how we can integrate transport with information technology solutions so that people have good information. And also we're focusing on green mobility. And then finally, URA and LTA in their their Transport Research and Innovation Program, looked at how people can enjoy smooth and seamless travel experience. So these are the goals set out for the next 1 to 2 decades, and we are trying to contribute to this. When you look at transport systems in this categorization, which on the horizontal axis looks at the system performance, speed, its capacity, also its reliability and image with people, and on the other hand, on the vertical axis, the investment cost, then you have, on the one hand here in the upper right corner, we have rail-based systems such as the MRT or the LRT here in Singapore. They have the highest priority in terms of right-of-way. There is no intersection. There's typically no signal lights. And on the other hand, you have buses and taxis and possibly some individual vehicles for first or last mile, which have the lowest priority in terms of right-of-way. You have intersections. You have to deal with traffic jams and so on. So they are typically quite a bit slower, especially during rush hours. But of course, also the cost is much less. And there is, in this continuum, there is a gap in between, which in many other cities is filled with tram-based systems, which are a good compromise between system performance and cost. However, Singapore has decided against tram-based systems for a number of reasons, one of them being that land is very scarce here, and any rail-based system on the ground would require additional road space, which already today is taking up as much space here, almost as much space in Singapore as housing, for example. So we can't do that. This here emphasizes this capacity gap. On the one hand, we have buses, even the largest buses, less than 150 people in one bus, whereas in a rail-based MRT system, we can have up to 2,000 people in one train. So there's a very significant gap, almost a factor of 10 in between. And also, when you look at the systems, here in orange, you have the MRT system, and Singapore is one of the best in the world, obviously, but still, although it's quite fast, it is reasonably sparse. It does not address large parts of the island. Shown in green here is the bus system, which is much denser. It addresses the entire island, but it's also quite a bit slower. It has to deal with traffic jams and so on. And our investigations show that there are quite a few high demand travel relations where people want to go from A to B in the Singapore public transport network, which could be served more efficiently than by conventional systems. And we were fortunate enough that we got great support by LTA in this, which gave us 3 months worth of tap-in, tap-out data so that we could analyze in very much detail where people actually want to go from A to B and where they're changing and so on. And so this brings us to our idea. What you see here are what we call SRT, semi-rapid transit corridors. These are the top 10 corridors where people want to go from one place to another based on those data, which were from 2013 that we analyzed. Some of these relations, if you are from Singapore, you will recognize is where right now MRT lines are being built, but not everywhere. So there's quite a bit of potential to do something to improve the performance of the public transport system. And here we go. So that was too fast. That's the basic idea. There should be a video playing here now, but we'll have to do without that. Now we have it, sorry. Thanks. So the basic idea, you have individual feeder modules coming from the neighborhoods, which then might join electronically into what we call a platoon when they're on the main road, split up a little bit again, join again, then split up, go into different neighborhoods. This is the very basic idea. I will talk about this in a bit more detail. What you see down here on the left side is the demand for travel. Here we have the morning rush hour. This is the evening rush hour. And typically, this change in demand is addressed by changing the frequency. So in the morning, bus comes every 2 or 3 minutes. During lunchtime, maybe only every 10 minutes. Which is good for the operator because they can optimize their economic performance. It's not so good for the user because I don't really know when will the next bus come. Will it come when I need it? With this kind of system that we are researching, you have another way of dealing with this, which is to change the number of modules that you're running. If there is low demand, you just run 1 or 2 modules. If there's high demand, you run a large train of maybe up to 10 modules, providing more capacity to your users. We are dealing with this in 5 research areas. We're looking actually at the vehicles themselves. How should they be designed? We're looking at the infrastructure. For example, how would an intelligent bus stop of the future look like? We are working with the assumption that all of this is electrified because that's the best way to have 0 local emissions. And that raises the question of what is the power demand that this is creating? Where do we need the power? And how does this influence the power grid? And finally, we look at the connection of the vehicles among themselves and to the central control system. So the module-based approach, I talked about it. Modules are vehicles which are driverless. They can act autonomously and are purely electrified. They have enough capacity to serve as feeders to go into neighborhoods and pick up people. And then when they hit the main roads, the trunk roads, they can connect or disconnect automatically. We also want to design them in such a fashion that they allow for fast boarding and alighting. And you'll see some ideas for bus stops in a moment. And at the moment, we're working with the assumption that we connect them electronically, not physically, because this has a number of advantages. And so this is the idea. You can have individual modules. You can have smaller or larger platoons of these modules. Now, Singapore is very innovative on the one hand, but Singapore is also quite conservative. So they certainly won't allow us to just explore all this on the public roads until it's really proven to be a very good idea. So at the moment, we're also focusing a lot on simulating the effects of this semi-rapid transport system. What you see here is one excerpt of Singapore where those of you who are from the area know here are the MRT lines, which are in existence or being built. And overlaid in green, you see the lines which we are proposing for semi-rapid transit, which have transfers with the MRT and also within the SRT system. And we are spending quite a bit of effort of modeling in very much detail, lane by lane, every signal that is out there, every traffic sign, and so on, in a high-performance simulation system, so that we can explore in much detail the effects that this semi-rapid transit system will have on how quickly people can go from A to B, and what effect this will have on the rest of the traffic. So here you see, in addition to the SRT system in green, the main trunk roads we have in sort of orange here. We have the feeder services, which pick up people in their residential neighborhoods and feed them onto the main roads. You also see some regions here which have low demand, where there is no service. This is also where there is no bus service today, for example. And then this will be supported, of course, by the existing bus network, which, however, will be amended to take account of the connections that SRT is offering you in the future. And one concept we're considering in the context of SRT is virtual right-of-way. You see this here. This is a lane where an SRT vehicle is coming. And when that vehicle is approaching, the lane in front of it is being cleared of individual traffic so that it can move very quickly. And you see right here, there are still other vehicles, but now they're asked to leave that lane so that the public transport vehicle really has full right-of-way, does not need to deal with other traffics. And this might be a very nice compromise between having dedicated bus lanes, which again is land usage because nobody else can use it, and having public transport vehicles stuck in traffic. When all this comes together, let's see. Yeah, this is a simulation rendering of what this will look like. You see some platoon coming here in the distance. It's running into one of these new bus stops that's splitting up before. We put a lot of emphasis on guidance of users. You see some guidance here on the ground, actually. You see people can, the doors are opening on both sides, so that makes for faster boarding or alighting. The short dwell time in the bus stops. Then when people have boarded or alighted, the trains start moving again, it couples again. Then you will see, here's a dedicated lane. Again, this is a virtual right-of-way lane. There may be other vehicles driving as long as there is no semi-rapid transit vehicle. Then you will see other regular traffic coming, using the roads. In a moment, we will have the next, here you see the next SRT vehicle. And at the moment, it's still stopping, so this is something we want to improve. Of course, the signal should know in advance that there's an SRT vehicle coming. And then it's decoupling here, and you see some vehicles coupling again. So this is the idea how we could have a very flexible and quite responsive public transport system for the city of Singapore. Of course, the bus stops on the top, they will have solar panels for energy generation. Energy is a key word. As I said before, the idea is this is all electrified. And then, of course, the question is, what is the energy demand? How do we get the energy to where it's needed? So we're also running quite a bit of simulations for energy requirements. This here shows you for the existing bus network, assuming that it's run 100% with electric buses, what is the energy density in Singapore? White is very low energy density to dark blue or even black is the highest energy density. Of course, you see downtown, there's a very high density. That is very useful for deciding questions such as where to place charging stations, where does the power grid potentially need to be modified to get the energy which is not needed today because we don't have electrified transport but will be needed in the future. And one final comment, of course we can't do it all just virtually by simulation. Eventually we want to implement these things in reality and run real trials. So we're working together with NTU for the CTRAN test track, where we will try our signaling ideas, our bus stop ideas, and we're also looking forward to a cooperation with Siemens for implementing the SRT system in the future. I hope this is giving you some idea of what we're trying to achieve here. Thank you very much.
Thank you very much, Ulf. And that brings us to close to the end. There is a map here again of the world, and all these activities that we show you here, of course, are also taking place in other parts of the world through the connections that the individual units that you saw, MIT, TU Munich, and NUS and TUM have throughout the world. For example, everything, the complexity science work is happening in the Santa Fe Institute, connected to this complexity science hub in Vienna, connected to our work here in Singapore, and of course with the NTU in Singapore, where the complexity science unit is also stationed. You see many of these collaborations not only in Singapore, but across the globe. And this map here is actually like an advertisement map for Singapore, because it shows the countries and the density of the number of the people participating in these massive open online courses on future cities, on livable cities, on smart cities, on responsive cities that are all coming out of Singapore. And you see many, many images in these MOOCs from Singapore, of course. To close up, to come to conclusion, it is clear now after these 10 years that Singapore has created the world's largest future cities laboratory as a living lab. Its MOOCs reach more than 120,000 people in 170 countries by now. And we also can see, we think, that Singapore can start to benefit from the great results in planning, transportation, and livability. Singapore doesn't go the path other cities sometimes go, that they get a nightmare when planning is suddenly attacked, as they think, by findings from AI and big data analytics. Here, in this lab, together with these units, we can explore what the advantage and disadvantage of each of these methods is. The great results and solutions are also suited for global exports. You heard that this morning, and we think with these solutions that you saw here, or proposals, that will become very clear. And the great entities increasingly work together, and with Singapore universities, industries, and agencies, and that brings us back to Mr. Huang's talk before. We have many, many different connections, cannot even show them on one page. It's all of those from the great entities and the agencies here in Singapore. And it's more and more and more. We could go on and on and on. It's a miracle that we have arranged the data exchange between all of them. It could and has to be much better in the future, because then we can do even better and faster work. One of the nicest experiences was this. Huang also mentioned that, this experience of engaging in urban design at URA together with our researchers, with your planners, really not being afraid of big data or planning rules, but combining everything into a very lively, large living lab, Singapore. And with that, I want to end and thank all of you, and especially my co-referenten, as we call it here. Thank you very much.
Thank you very much. Thank you very much, Professor Schmidt. We have some time for questions from the audience. If anyone would like to have a question for either Gerard or his speakers this afternoon.
Yes, he needs a microphone.
Thank you very much. Interesting and inspiring talk. I wonder, you're trying to be comprehensive and cover as many topics as possible with regard to the smart city. I noticed that two important issues are not covered in your studies, and this is waste treatment and waste facilities in general, which is definitely one of the major issues related to big cities. And second, more important for Singapore, the transport of containers. Big trucks on the road, which I believe it's not less important than public transport. And perhaps your SRT system could contribute in this direction as well.
Thank you very much. It was first not a question, it was a statement. But we do not want to be comprehensive. We cannot, because we are not a city planning authority or a total city research unit. But these are all the combined efforts that have been done so far. However, if you talk of waste, this second project I showed from Shanghai Jiaotong and NTU together, this goes in this direction, of course, on a small scale first, and could be expanded. But it is a hot topic in the true sense of the word, with the waste to energy approaches that the city is taking, which are not on our research agenda. This is correct. And the second one also, we are quite aware of the already ongoing efforts of the city to solve this problem of these huge trucks running around in the whole city through underground connections and similar things. Maybe the TU Munich approach could also be used for that, as it is in some German cities, but on other, just on tracks. Yes, Fang, yeah, you have an answer right away.
I just wanted to respond to the second question. So actually, indeed, freight movement is an important part of the urban transport system, and the agency is paying a lot of attention to it. So Mr. Huang mentioned the urban freight and heavy vehicles study, where they're actually putting GPS transponders on a large number of heavy vehicles, including container trailers. So we're still at the early stage of the project where we are understanding movements of these trailers. So the target is collect data first to understand the movement, build the models to simulate that, and then design solutions to maybe minimize the movement of these heavy vehicles inside city areas and minimize their carbon emissions and things like that. So there is effort towards that direction. Thank you.
Are there any other questions from the audience? Yes?
I haven't got a question quite so much as a comment, but you can treat it as a question if you like. I mean, as you were listening to this really very impressive portfolio of projects which are related to the urban systems, it just came to my mind, as I've thought sometimes in the past. We are primarily scientists and technologists from very often very technology-heavy universities. And we know from our own experience in Future Cities Laboratory that there was a sort of gap in terms of people and how people will use the systems that we are designing. So my comment really is that as we go forward, as CREATE develops and new programs, it seems to me inevitable that we will have to alter the way we do research so that it becomes much more people-centered. And as well as designing technologies, which we hope people will find useful in the future, we need to understand people's aspirations and perhaps help them influence the design in the first place. And I feel at the moment it's a little bit of a sort of gap in the portfolio of CREATE. And I don't know if you'd like to comment or if one of the others would like to comment.
I just can say I couldn't agree more to this. This is really true. And this work on user engagement, citizen engagement is exactly that. And we think the next step in the city development has to be done with the citizens and not for the citizens. And I think that will lead us to the correct next step, because then also technology is so far advanced that this is easy, or more easily possible. with that, I don't want to steal any more time from the next session. Thank you. And also I want to point out this book that Peter Edwards was showing this morning. It's a book, but this is the last exemplar, so it has to be reprinted. But if you are interested in that mitigation strategies that he showed for the cooling Singapore, it will be available at the Future Cities Lab. So with that, thank you very much again.